Okay? So that is the logic of taking 176, out. So you have what you call is BC frequency. I reduced that by 88, and then you have LWR, and I reduced that by 176, and whatever the frequency is, I just use that Candida-Ferreira's equation and look at this thing go, Look at this thing go. Now, another one, this is the case 2. What I have done, these ones are the, suppressing. These ones are also suppressing. So I took -8, and we know these -8 came from somewhere. I found this having an effect on the data, giving a median, a mode that was not being observed before by 8. So I took that out. And then you see 11 here, 22 here, right? Because this one is always producing overexpression, and there is a theory behind that, right? So we see that. Okay. The third case I'm taking is that and doing a little bit more, okay? Doing a little bit more. This one is -8, -16. It used to be -8, -8, okay? Now the fourth one, look at that. This is a complete 11 is your BC, 10 is LWR. This is the size of the tumor and how much I'm subtracting or adding to the originally observed frequency. It's all here. And you can see that these are coming close, right? These two. Now, does that make a sense? It sounds to me, if you are working in retail, what is happening is that you have basically a segment which is 22 to 30, and the other one which is 31 to 38. Since they overlap, so some of the responses will overlap, But does this make sense? I question that to myself, and that is called Egger's problem. Okay, you have a good result, but it's too good to be true, Sarah. Okay. Yep, and I request to read these two papers.
Is it kind of like with pilot studies? Sometimes you get.
Oh yeah, right.
More,
yeah.
The clinical trials.
Yeah. I remember what you said that day. I didn't forget, right? So many times they have more effect than they can sustain. And my belief is that what was happening here, consistent all the time, So that's the point I'm trying to make here, that. Okay, so I'll let you read. After doing all these regression and simulations and everything, I got the original data, all those 4 cases, corrected cases, and I have the R-square and in South Dakota State, onion and sunflower. I mean, sunflower is 10 feet long. It's a very, very big size asymmetry, right? So these guys over here are bigger ones. They don't need to be produced. Okay? Now, so visual analytics, meta modeling, okay? What I'm trying to say that this is wrong. If you take just original data and you don't apply these methods, this is the conclusion you will come up with, that these two were above threshold and these were not been found yet. Not one journal. I have looked for 3 months looking for evidence of this thing. Since I didn't find, I went on doing something which is interpretable. So here, the PLOS publication, they said that, well, if I challenge these BC mutants, they don't improve the fitness more than 70%. And there is a metabolic blockade into that. And they got the publication. For the first time, I'm trying to say that there is not a metabolic block, that they started with a very high genetic fitness. And if you challenge that, there is not much space to go. It is unfortunate that the scientists don't find what is the in situ genetic fitness. They take a mutant and they start challenging it. So that is the original thought. I have never found anywhere in any publication that says in situ genetic fitness, has some contribution. But that is my interpretation, Okay, now validation. Somebody can say that, well, I don't believe in any of your hypotheses. Here is a residual plot on original data. I know this is high. I know this is high. I know these are suppressed. I know these are suppressed. So why don't you bring this thing down, and make a simulation? These two or one of these two are at higher frequency. So go ahead, follow these things. That these are the dynamical properties of gene expression for LWR and BC, right? That the hypothesis is just bogus. I can take that criticism, and I just went a step, and So I did the simulation, and in second simulation, second step, second generation, I found this frequency. You have almost 90% decrease in 25K here. These frequencies were above 600 or above 400. Look at how the range is 0 to 16, basically. And you have this recessive and dominant, this 75K at the, whatever you wanted here is right here, So basically you have ignored those two hypotheses, and you are just going by what you see in the residual plot from the original data, right? Well, that's good. That's good. You're doing that, But the sad part is this. Look at that, the R square. I mean, you don't have to believe anything that I'm saying. Just believe the diagram, believe the, matrix algebra. You can believe that. That has been with us for more than 300 years. So this is bad. I mean, this is really, 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 really bad. This is really bad. I mean, I haven't seen one paper where it says that the intra and interspecific competition leads to this kind of equation where quadratic and cubic equations are just about same. I haven't seen that. So what?
Can I get a quick break to change something?
Sure.
Thank you.
Slide, what I have done is applied the correction factor. Even with that, look at the pattern has just switched over here, So what I'm trying to say that if I do the correction factor, look at this thing. This is high, and still it is increasing this way. So the conclusion I'm trying to make is this one, that you need to include, well, go ahead and read.